For decades, Uranus was a solved mystery. It was the tilted planet. While other planets rotated more or less perpendicularly, Uranus rotated almost completely on its side, tilted 98 degrees. Somewhere in the distant past, a giant planet must have collided with it, flipping the planet over like a billiard ball that had been hit. The idea was simple, intuitive, and convincing enough that most people never questioned it. The strange thing was that the more scientists studied Uranus, the less this explanation seemed to work. Today, Uranus is no longer just the tilted planet. It has become one of the most perplexing worlds in the solar system, and understanding it could change how we think about all classes of planets across the galaxy. The first problem arose when researchers tried to revisit Uranus's history. A giant impact could certainly tilt a planet. The early solar system was full of collisions. Yet computer simulations repeatedly produced an interesting result. Some collisions created the correct tilt but distorted other features. Others preserved the planet's structure but couldn't explain its orientation. Each solution seemed to create a new inconsistency. What seemed like a simple accident was becoming increasingly difficult to reproduce. Then scientists noticed something else. Giant planets are expected to radiate heat from their formation. Jupiter radiates, Saturn radiates, Neptune radiates. Uranus radiates almost none. Measurements revealed that the planet was releasing surprisingly little internal energy into space. Compared to expectations, it appeared almost motionless. This was extremely strange. A planet as large as Uranus should have lost an enormous amount of heat even after billions of years. Instead, it seemed unusually quiet. Suddenly, the slant was no longer the only mystery. Now there was another question lurking beneath the clouds. Why did Uranus appear so cold compared to planets that should have evolved in similar ways? Humanity's only close look at Uranus was in 1986, when the Voyager 2 spacecraft passed by it as it traveled through the outer reaches of the solar system. Scientists hoped this encounter would shed light on the planet's nature, but something new emerged. Uranus possessed one of the strangest magnetic fields ever observed. On Earth, the magnetic field is roughly aligned with the planet's rotation. Uranus's is very different.
Its magnetic field is dramatically tilted and skewed away from the planet's center. It appears strangely displaced, as if the magnetic engine producing it were operating from the wrong place. This discovery showed that Uranus's internal structure is far more complex than researchers had assumed. For years, scientists imagined Uranus as a relatively simple, layered world: an atmosphere on top, dense icy materials below, a hidden internal structure further deep. But increasing observations pointed to something more complex. Models began to suggest that the planet's interior might contain regions where materials mix and separate in unexpected ways. If these layers impede the movement of energy, they could trap heat deep within the planet. In other words, Uranus may not actually be losing heat, it may just be hiding it. This possibility completely changed the debate because it meant that Uranus wasn't just an unusual version of another giant planet. Some researchers began to suspect that these mysteries might be connected. The missing heat, the unusual magnetic field, and the planet's strange interior may not be separate problems at all. They could be different consequences of the same ancient event hidden deep inside Uranus. If that is true, then the planet is not simply tilted. It has been evolving differently for billions of years. It could fundamentally represent a different planetary evolution. And this realization created an even bigger problem: Neptune. For decades, Uranus and Neptune were treated almost like twins. They have similar sizes, similar masses, and belong to the same category of worlds known as ice giants. But the more carefully scientists examined them, the less similar they seemed. Neptune emits far more internal heat. Its atmosphere is more active, its weather is more severe. Uranus differs in almost every important aspect. Two planets that looked almost identical from afar gradually began to appear as products of very different histories. Even the category itself began to seem too simplistic. Around the same time, another realization emerged. The only spacecraft sent to Uranus had spent only a few hours near the planet. Everything humanity thought it knew about this enormous world was based on a brief encounter that took place decades ago. Generations of planetary scientists have had to work with limited data, gleaning new clues from observations made with distant telescopes. In a way, one of the largest planets in the solar system remains largely undiscovered.
The more significant Uranus seemed, the less information we had about it. Then exoplanets changed the story completely. As astronomers discovered thousands of worlds around distant stars, they found that planets similar in size to Uranus and Neptune were among the most common in the galaxy. Uranus was no longer an obscure planet on the edge of our solar system. It became one of the most important points of reference available. The problem is, scientists realized they didn't really understand it. Many of these distant planets are similar in size to Uranus, but differ significantly in density, temperature, and atmospheric composition. Researchers are increasingly suspecting that several different types of worlds are hidden within what was once considered a single category. Understanding Uranus could help explain a vast majority of the planets in the universe. Recent studies have made the picture even more complicated. Instead of being shaped by a single catastrophic collision, Uranus may have experienced a far more complex history involving numerous collisions, orbital interactions, and long-term internal changes. Instead of a single event creating the planet we see today, its current state may be the result of countless processes that have evolved over hundreds of millions of years. This possibility is difficult to visualize because people naturally prefer simpler stories. A single massive collision seems satisfying. A chain of interconnected events stretching across geological timescales is not. Yet nature often favors complexity over simplicity. Modern telescopes continue to reinforce this lesson. Researchers studying Uranus have observed seasonal changes unlike those on Earth. Due to its extreme tilt, some regions of the planet experience decades of sunlight followed by decades of darkness. But the atmosphere doesn't always react as simple models predict. Cloud systems appear where they shouldn't. Activity emerges where scientists expected calm. Once again, the measurements didn't fit neatly into the story. And this may be the most important thing we've learned about Uranus. Every major discovery was expected to simplify the planet. Instead, each discovery revealed another hidden layer. The tilt led to questions about collisions. Collisions led to questions about heat. Heat led to questions about internal structure. Internal structure led to questions about magnetic fields. Each answer changed the meaning of what came before.
From a distance, Uranus seemed like the simplest giant planet in the solar system. Closer inspection, however, reminded us that reality is often far more complex than the explanations we give it. And if a planet we thought we understood for generations can surprise us so much, it's worth asking how many other things seem simple because we haven't looked closely enough.